Hello, everyone. Just a second for everyone to join the session. Okay, I think we can start. So, hello, everyone again, and welcome to our live session, AI in Healthcare from Infrastructure to Impact. Thank you, everyone, for joining us today. And we're really excited to share all the insights and discuss relevant questions today. So please feel free to introduce yourselves in the chat and leave your questions, which will be addressed after the presentation and later during the panel discussion segment. And now let me introduce our amazing speakers for today. So we have with us Maksym Voitko, Head of Data and AI at Honeycomb Software, with a strategic view on how organizations can adopt and govern AI responsibly.
Hello, glad to be here and to talk on this, I guess, super important topic about AI, challenges of AI in healthcare.
Thank you, Maksym. We also have Andrés Fernández, Partner Solution Architect at AWS, bringing expertise in designing secure and scalable AI solutions on the cloud.
Hi, everyone. It's great to have you here. As Tatiana said, my name is Andrés. I'm a Partner Solutions Architect at AWS for 3 years already, and very excited about what we are going to talk about today.
Thank you, Andres. We have Pamela Pineda, Partner Solutions Architect at AWS with deep expertise in compliance and helping organizations build resilient architectures.
Hello, everyone. As Tatiana mentioned, I work together with Andres, and part of our role is to support partners developing in AWS and exploring new solutions. So happy to be here.
Thank you, Pamela. And we have Michael Watts, co-founder and CEO of Blum Health, NHS doctor, clinical informatician, and entrepreneur, who will share how these technologies translate into real-world clinical practice.
Hi, everyone. Good afternoon. It's a pleasure to be here. Yeah, I'm Michael. I'm a doctor by background, still a doctor now and then. But yeah, it's a pleasure to be here. Some fantastic partners in the room as well, and we'll hopefully have a really exciting really exciting opportunity to have a conversation. So thank you.
Thank you, Michael. Thank you, everyone, for joining us today again. And to our attendees, on our agenda, we have a presentation from Maksym, who will tell more about AI challenge in healthcare and share a real-world case. Then we have the presentation from Pamela and Andres about how AWS can support products on that journey. And after that, we'll move to panel discussion and questions. So stay with us. And thanks, so Maksym, the floor is yours.
Thank you, Tatiana. Just give me a second to share my presentation. Yeah, I hope
everything is okay.
Can confirm in chat that everything okay. So the topic of my presentation is AI challenges in healthcare. So we'll talk about real world case study of self-hosted LLM in UK healthcare environment, regulated environment. So I am Maksym Voitko, again, Head of Data and AI at Honeycomb Software. So let's go to the specifics. So what is the business context and constraints? So first, it's healthcare. In healthcare, it's compliance. It's highly regulated environment. So, and according to UK Data Protection Act, apart from everything else, basically healthcare products cannot use OpenAI or Anthropic servers because they are located outside of the UK. So the technical limitation we face is that at the time of the implementation, AWS Bedrock models were not available in London region. So that was a blocker for us. And of course, we had some budget limitations we needed to consider that. So this translated to the requirements that the and product should be compliant within UK, cost efficient. Probably that means in technical terms that we need to be able to scale to 0, ideally because of the load profile. It should be production ready because it's a healthcare product for real users and of course secure. So the stack that we used for that to deploy open source LLM on Kubernetes is models like Llama 3, Mixed Bread with Llama. This all was deployed with the help of AWS Elastic Kubernetes service. The autoscaling that we needed was supported by Carpenter, and we use AWS GPU nodes, spot nodes for more optimal cost utilization. Of course, everything was written in Terraform to support infrastructure as code approach, so this could be easily maintained and reproduced for other projects. So what's the technical architecture of the case? So the general context of the system is that user uploads some documents to S3 bucket, which triggers AWS Lambda, which starts document indexer, which basically first does the OCR on the text, on the PDF documents, for example, or images with AWS Extract service, extracts the text, and then we basically, since we have variety of documents, the data is unstructured. And here comes the LLM solution. So we deployed we use LLM to extract the structured output from the unstructured text and put it in a database. So the solutions that we used for LLM hosting is EKS with autoscaling groups on the pod, and on the pods Llama is deployed wherever, so we could be flexible and use different models. Currently, we use Llama 3 and Mixed Bread for the embedding model, and that's basically what solved our problem. But the tricky part here is that to support all this, we needed to use EBS for the model data, and we faced a small bottleneck that EBS is availability zone bound service, and when the Carpenter scaled the nodes from 0, so on the first iteration it could scale in availability zone A, for example, then scale to 0, and then when it scaled to availability zone C, so the pod couldn't use the EBS from availability zone A, and there was a delay in starting up the model. This first problem. Another problem is that we increased the cost drastically because basically we needed to replicate the model data in all availability zones. In our case, it's 3 availability zones. So that's the architecture diagram for this. So basically that GPU node and pod matched the availability zone and the EBS. And we solved this with by introducing EFS instead of EBS. So the advantage that it provided shared regional mount. It supports burst throughput for parallel load, and that led us to simplified call start and better availabilities on flexibility. So it's also decreased the costs for storage for our scenario, because all the nodes and pods in different availability zones used the same EFS storage. We didn't need to support other types of replication here. So what's the business impact we achieved? So our solution is modular for future model swaps. or building RAG, so we could support other open source models. We unlocked generative AI features, but at the same time stayed compliant within the UK. And what's the most important, so now we have fully controlled environment, including infrastructure, data, and availability. So it's highly flexible depending on the project and business needs. So we can lean into the directions that we want. At the same time, we achieved 80% of GPU cost reduction by introducing the scaling that I talked about and decrease the cold start time for the first start of the model instance. So the lesson learned from this case is that infra is a product accelerator, and if you have flexible enough architecture, so it allows you to develop to cover all the business needs and pivot across the way. If not, it could be a blocker for you. Also, that you always need to think compliance first and to cover this because of the risks, especially in healthcare domain. And details matter. So as we learned the lesson with CBS and EFS. So thank you for the attention. Don't hesitate to contact me to discuss this in more details. So, and now I assume we'll have like a very short Q&A session for this presentation, right, Tatiana?
Yes, we have a few questions to you, I guess. So, the one is from Norm, says that classifying and codifying unstructured medical data into structured output is not easy. How do you tell the LLM to classify the unstructured text into classes like medications, lab results, conditions, vitals, and etc., and just a simple system prompt or something more sophisticated?
So that's a little bit responsibility of other, I would say, team, the usage of this model. So I focused on my team more on the infrastructure supporting this, but so I guess that it's important to when developing in a product to start from simple things and to start from system prompt first and prompt engineering, and then move to some more advanced techniques. So currently we are at the phase where we looking into fine-tuning, and this is basically what can achieve where we can achieve much better quality of the model outputs, specifically for the medical domain and for supporting different categories of the data. Because the only other option is to train your own medical LLM, but I guess it's a bit too pricey.
Thank you, Maksym, and thank you, Norm, for the question. And Amy asks if you have Carpenter configured to use spot nodes to save on cost.
Yeah, so sorry, what's the question in here?
Do you have Carpenter configured to use spot nodes to save on cost?
Yeah, so I guess somewhere here I mentioned that yeah, we have Carpenter to support our after-scaling needs, and we use both regular nodes and spot nodes. So spot nodes to decrease the cost by introducing basically queue and dead letter queue when once we acknowledged and processed the request to the LLM. So basically, since it's still stateless, if we spin up a new instance, a new node with LLM, it's fine for us if we keep track of the requests that we have.
Thank you, Amy. Thank you, Maksym. And Jamie asks, what kind of costs can one expect from implementing this architecture?
that's I can give like a precise number, of course, here, because this is a solution of our client. But generally speaking, this is the cost of using when using EKS. There is a very small overhead in terms of costs over using like EC2 instances, comparable sizes, and of course here we need to pay for GPU nodes, which can be pricey, from like a couple of dollars to tens of dollars, I guess, per hour. But the beauty of this solution is that if we have the load profile where we have spikes and the periods where we don't have load at all, like usually for some phases of the product, this is the case. So we don't use GPU nodes at all. We just shut down the GPU node pool. We scale it down to 0, not to consume costs, and that's the main, basically the main line in the budget at the end of the month.
Okay, thank you, Jamie, and thank you, Maksym. Thank you, Maksym, for the great presentation. We also will answer and ask more questions a bit later. And I also see the question from Saif. I guess we'll answer that after AWS presentations, as it feels more relevant to that. Thank you, Maksym. And now we happy to welcome. Now we're happy to welcome Andrés and Pamela. Please, the floor is yours.
Thanks, Tatiana. So let me share my screen. Can you see it?
Yes, everything's okay.
Okay, perfect. So thanks for the introduction, and thanks, Maksym, for talking about the use case. As we saw, when they were implementing this, Bedrock wasn't available in London region, but now it is, and we continue to expand to other regions. This is why today Pamela and I, we want to talk to you about how you can advance your healthcare mission with generative AI at AWS. So for today, first of all, we are going to see healthcare use cases in AI. We are going to talk about foundational models and how you can implement these healthcare use cases with Amazon Bedrock. And then Pamela is going to talk about AWS-powered healthcare solutions, and finally, about AWS AI services that we can offer you to accelerate your mission. So first of all, what are the top generative AI healthcare use cases that are powered by AWS? So GenAI can support clinicians' workflow by listening to patient conversations, summarizing clinical notes, and consolidating records from various sources. For example, for care management, systems can efficiently review records for registries, analyze individual records to identify risks, and segment groups for targeted interventions. To improve patient engagement, GenAI can provide self-triage capabilities, for example, proactively communicating with the patients. As for education and research, GenAI can here boost research efforts by automating data cleaning and enabling cross-patient queries to identify clinical trial matches. And finally, for enterprise functions, you can implement chatbots that serve educational needs or can support internal questions from different departments, such as it could be IT, HR, or any other kind of customized internal information. So we are talking about GenAI, and GenAI today is mostly based on foundation models. But why foundation models? So the size and general purpose nature of FMs make them different from traditional ML models, which typically perform specific tasks like analyzing text for sentiment, classifying images, and forecasting trends. For example, with traditional ML models, in order to achieve each specific task, customers need to gather label data, train a model, and deploy that model. However, with foundation models, instead of gathering label data for each model and training multiple models, customers can use the same pre-trained foundation model to adapt various tasks. FMs can also be customized to perform domain-specific functions that are differentiating their businesses, using only a small fraction of the data and compute required to train a model from scratch. So this innovation that happened a couple of years ago, when it started being more implemented, has shown very exciting use cases, but it's still early days. And this is based in one key point, which is the transformer architecture. And the transformer architecture is a type of neural network that is efficient, easy to scale and parallelize, and can model interdependence between input and output data. And also one key feature is in-context learning, which shows potential on a range of applications from text classification to translation and summarization. And this new training paradigm provides pre-trained models with instructions for new tasks or with a few examples instead of having to train or fine-tuning whole models on data that has to be labeled. And of course, this technology comes with a few challenges. So for example, what about the technical challenge? There can be skewed data that may lead to unfairness or tangible harm. Complex models create challenges in accountability and interpretability, or perhaps smaller organizations may struggle with the computational resources that are required to train the models using GPUs or to perform the inference. Also, there may be ethical considerations, such as privacy violations or security breaches that may result from exposing patient data during training. And also, there may be organizational barriers, such as implementing generative AI might be difficult without alignment on the organizational goals that could lead to inefficiencies, or not having a clear account structure can lead to potential risk and biases that might go unnoticed. So AWS customers asked us how they can quickly take advantage of what is out there today and what is going to be used there tomorrow. And we identified 4 main requests. One of them is the easiest way to build Gen AI with foundational models, also having the most performant infrastructure for generative AI, being able to power Gen AI applications on AWS, and of course, having the flexibility to build them using either your own foundation models or the different range of foundational models that we provide. So how does Amazon Bedrock work? So Amazon Bedrock is a fully managed service that makes a range of powerful foundational models, let's say from Amazon and leading different AI companies such as AI21 Labs, Anthropic, Meta, or Stability AI. With Bedrock's serverless experience, you can quickly experiment with foundational models, privately customize foundational models with your own data, and easily integrate and deploy them into your application using familiar AWS tools and capabilities without having to manage the infrastructure. Also, agents for Amazon Bedrock make it easier for developers to create Gen AI-based applications that can complete tasks and respond with more accurate and relevant answers using retrieval augmented generations. So what we know today as RAG, which can be implemented with knowledge bases. And of course, at AWS, security is our top priority, and you evidently need to make sure that all your data is kept private and secure. This is why at AWS we have support for standards, including GDPR compliance and HIPAA eligibility. So here it's critical, and you want that all your data is encrypted and does not leave your virtual private cloud. For example, when the customers want to customize the base foundational model with Amazon Bedrock, the customer-specific data is used to train a separate copy of the base foundation model. This customized foundational model is private to the customer. And here, neither the customized foundational model nor the data that was used to customize the base foundational model gets shared with any other customer or is used to improve any other models. This is all kept private just for you. And after seeing this, now Pamela is going to walk you through how AWS-powered generative AI healthcare solutions can help you innovate in your journey.
Exactly. Thanks for having me here again. And I will walk you through to some purpose-built services that AWS offers for us to build healthcare solutions. And of course, how can we leverage them? So if we think about the top cases, probably some document-related things will come up to your mind. Nowadays, healthcare companies are started with lower risk but highly valuable operational use cases, such as health record documentation, boost medical scribe efficiency, create patient-friendly consultation recaps, patient billings, and document-related things. But the future on Gen AI is to use this information to make decisions based on each patient, so more personalized and with more generative AI capabilities. So as we were seeing in the last slide, we noticed that some of the top use cases are document related. In this case, what type of data do we have for healthcare? We know this as unstructured data, but what is really unstructured data? In medical field, we notice that we have information in many different formats. For example, insurance claims, clinical notes, images, bills, handwritten reports, and more. So putting all together, it's a challenge. And how AWS is supporting customers in this field. Here you can notice three services that you can use. We are going to go deeper into some more. But the point is that AWS is offering purpose-built services to support the healthcare industry. So from behind, probably, as I was asking you some minutes ago, what comes to your mind when you think on a use case for healthcare, probably is something related with a chat. But how a chat looks from the technical field in the background. If we notice, in the left side, we have a high-level architecture, and we can split these services into two sections. The first one is how we field the information, how we feed the database with this unstructured information that we have, and then how we consume it. So if we pay attention at the diagram, the first step is the feeding information. So the user is uploading or saving their documents or their image in an S3 bucket, which is basically where you store your information. And after that, we are using Textract together with a Lambda to store the information in a vector database. A vector database is basically a representation of the real world into a numerical way. And okay, in this side, we have the information already stored. Now, let's say you as a patient or as a doctor want to know what happened some time ago, you go to a chat, ask the question, which is known as a query question or, the information you want to retrieve. So you will go into the chat, and from behind the AWS Lambda, together with Bedrock, which is the intelligent layer, we can call it like that, will retrieve the information from the vector database and will give you your reply. And here, Andres already mentioned some some models available. Just for you to know, Bedrock is a serverless services that allows you to access to top foundational models. For example, we have here Anthropic, the latest update with OpenAI, and also we have Amazon models with Nova Suite. And on the right side, we see the user experience. You ask a question and then you receive the answer. And this slide is basically just for you to see that there are purpose-built services that you can use to build accurate solution for healthcare field. And I will highlight some of the services that we have right now. And for transcribing, as its name says, we have Amazon Transcribe Medical, and we can use this to get conversation for clinical documentation, capturing phone calls in pharmacovigilance, for example, or subtitling telehealth consultations. Amazon Transcribe Medical provides transcription expertise for primary care and specialty care areas such as cardiology, neurology, pediatrics, and more. Here we have a Comprehend Medical, and the big question is, what can I do with Comprehend Medical? These services uses advanced machine learning models to identify medical information such as medical conditions, medications, and determine their relationship to each other. For example, here we have in a traditional call, medications and the dosage. And from behind, you can access Comprehend Medical through a simple API call. There is no machine learning expertise required and not complicated rules to write. And last but not least, we have AWS Health Scribe. And the highlight of this service is that you can see this as let's say an agent person that is supporting you to understand the notes, for example, in an appointment. So some curious things for this is that it can provide you with participant role detections. This means that that you can distinguish the patients from the clinicians in the transcript conversation. Also, it transcript sectioning, which categorizes transcript dialogues based on their clinical relevance, such as small talks, subjective, objective. And also it allows you to identify clinical entities. This means that you will be able to identify medical conditions, treatment mentions in the conversation, and who were involved into these conversations. And this is just for you to see. If you click one more time. Exactly. So this is just for you to see how transcribe could look like. So in the left side, you have the conversation, and if you pay attention in the right side, you will have the summarization, the assessment, and also the plan for what the conversation was about. So thank you, and we are happy to take questions.
Thank you, Marlon. Thank you, Andres. A few questions that we've got before that was basically what mechanisms do you recommend using to implement guardrails?
For guardrails specifically, we can use Bedrock. We already mentioned this service in this presentation, and there is a feature in Bedrock which is called Bedrock Guardrails that allows you to, for example, add disclaimer on the conversation. This is the please, you ask a healthcare health question or advice, and you can add the disclaimer such as please check this with a doctor or something like that. So we can add disclaimers. We can also hide or identify personal identifiable information, so we don't share more than we need, and patient's information is secure. And also Bedrock guardrails allow you to filter topics. Let's say that you want to implement a chatbot and you don't want your customers to start asking questions about medical treatment. You can block this kind of topics and add the disclaimer.
Thank you. And I guess this one is interesting. Is what are the benefits or drawback of using AWS Bedrock FM? And I would imagine we would use the data stored in S3 with Bedrock to retrieve results for RAG. That was a question from Steve.
Okay, one of the benefits is that you can leverage the top foundational models that are available in Bedrock. We saw Cohere there are Nova models now, OpenAI, so you can get benefits for top foundational models available in the market through a single API, which simplify the process, and also you can apply guardrails to build in smart applications. And regarding the information you mentioned, in the architecture that I showed you, this is what we call RAG, which is the knowledge base stored in this vector database. So we use Bedrock and the models to retrieve the information, translate this into a natural language that we can understand, complement the information, and then reply it to you.
Just to share some more details, Jeff. So the benefits is that Bedrock is the easiest way to deploy GenAI, and it gives you this managed service serverless where you don't need to handle the infrastructure, right? If you would think about the trade-off that you would do here is that you may be losing control on managing every single aspect of the infrastructure. However, this is something that also it takes away precious time from implementing things that actually bring business value, right? So in this sense, you don't have that level of customization, such as if you were handling the GPUs for training, for inference, setting up all the infrastructure, but you have this serverless managed service that makes it the easiest. And as for the data in S3, that's right, you can have the data stored in S3. And here the good thing is that you don't need to make RAG on your own. There is also a feature called knowledge bases where you can just have your data in S3 and essentially have a RAG functioning with it.
Thank you, Andres. Thank you, Pamela. And thank you for great insights and presentations. So I guess now let's address a few challenges and questions that we've got before the session. And a lot of them touched on accuracy and reliability, which in healthcare is obviously critical. So I guess one of the questions we'll start with is how to validate the accuracy, or how we can say the suggestion provided by the AI is correct, as this is a domain of healthcare, and if anything goes wrong, it can cause a big blunders. Guess we can start from a more technical perspective from Maksym.
Yeah, so there is, I guess, first of all, there is no AI model which can provide 100% accuracy. So that's just the design of AI, I guess. But I guess, so what we could do is introduce evaluations. And in healthcare, the importance of evaluations is like at the top level. So I guess there are even a lot of startups who are attacking specifically this problem, the evaluations in healthcare. But the more detailized and the more concrete and specific you make your evaluation set to the problems that you are solving, covering the more and more cases and running evaluations after every change, even of small change of the prompt. This gives you some understanding about the critical passes that's covered. And another way that probably there is still should be a human in the loop to provide 100% quality. Just our aim to minimize that involvement, human involvement, to as little as possible.
Michael, yeah, from the perspective of a clinician and someone building solutions in healthcare, like what do you think about that? And what does safe and reliable really need to look like in a clinical setting?
I would say, Maksym, don't be so hard on yourself. You know, the AI is, you're absolutely right, AI is not 100% accurate, but neither is a human. And I think we often lose sight of the fact that actually humans do get things wrong. Doctors get things wrong. I am one. Nobody's perfect. So what we have to look at is reasonable risk. And we have to think about what level of risk we can accept where the benefits still outweigh the risks. Now, the problem is that that's really hard to define. Is it 60%? Is it 70? Is it 80? Is it 99? Having a human in the loop still doesn't make it 100% accurate, right? Because actually, the paradox is that the human gets lazy. So it just trusts that the AI is right and just says, actually, I'm not even going to review it because I've seen it's got it right 9 times. The 10th time might be the wrong time. So we have to operate with caution. We have to look at the current state of the art. So there's lots of research out there that says, you know, for a specific care pathway, if there's this much harm across a population, or there's this much disease across a population, and therefore we want to aim to achieve the same or greater outputs. If we are achieving less, then the risk is higher than the potential reward. So therefore, we then need to put mitigations in place, which is all the humans in the loop and things like that. So this is the current state, and for as long as this is the case, it will slow down innovation and trust and adoption. So we have to, as important as development and engineering of AI is, we have to also manage expectations. We have to deliver clear intended use, and we have to use safety rails to be able to make sure that people use AI safely, but it still provides all the value that we set out to achieve in the first place.
Thank you, Michael. If we take a closer look at the healthcare, health tech industry, we've got also like a few questions that I think should be addressed to you. What products should we be creating to get closer to personalized medicine?
Well, personalized medicine is just one part of the opportunity, right? To be able to personalized medicine is more around things like genomics, because the whole point of personalized medicine is actually being able to create drugs that specifically target diseases of an individual, not a population. But you could also include personalized medicine to use things like AI to be able to deliver content, therapy, advice based on an individual's circumstances. So I guess there's 2 elements to personalized medicine. It's really simple. There's only 3 ways that you can change healthcare globally. It's stopping people going into hospital, shortening the amount of time that they're in hospital, and then making sure they never come back, or trying to make sure they never come back is probably a better, more accurate term. So what does that mean? Keeping people out of hospital, so that's preventative medicine, using AI to predict and data to predict disease and being able to mitigate it. Shortening the time that they're in hospital, so that's operational efficiency. How can we use AI to automate processes, reduce down administrative burdens, maybe even replace human requirements altogether so they can go back to doing their job of caring for patients, and then making sure they never come back. So that's effective discharge, fast discharge, safe discharge, and virtual care. So being able to support patients as if they were in hospital, but from the comfort of their own home or wherever their home they're living. So these are the opportunities to provide that kind of personalized experience that you mentioned, Tatiana, there. And this is where we should be focusing our energy, I believe.
And like from your perspective, what new breakthrough do you foresee in the application of AI in clinical medicine?
So there's a lot. There is a lot. So processing of documentation is a key one. So actually just being able to read words on paper and be able to process them in a more meaningful way. So for example, we're building a AI referral letter management solution. Well, we have an AI referral letter management solution that looks at a referral. It tells you how much risk is in that referral, and therefore it tells you how important that patient's care is right now and how soon they need to be seen. We're also building AI that can read a discharge summary so that a family physician can look at it and say, these are the tasks I need to do. These are the codes that we need to code. So again, looking at that coding capability is super important, not just from a output perspective, but also from a costing perspective and everything like that. When we have powerful AI, we can use it in the world of genomics and pharma to be able to automate things like clinical trials. So this goes beyond the clinical realm. And of course, we have AI scribes, which is a big focus, particularly here in the UK at the moment. We have some really sort of trailblazing AI scribe capabilities. So these are just some of the, I mean, that's all very sort of machine learning and NLP based examples. We haven't even spoke about computer vision and all the other opportunities that that brings with radiology and diagnostics. But effectively, we know that that level of AI and automation is going to change the way that patients receive care at scale.
Thank you, Michael. So, of course, the most popular theme is security as well, and we touched on it during the presentations. But a few questions directly from the audience, like how do we deal with data privacy and regulations when working with AI? And thanks the question to everyone. So, feel free to give your input here.
Yeah, I guess I start from the technical scene. So it's like super important to ensure that AI, on all levels of there is an OCI model where how the data is transferred and used, applied on the level of network, transport network application. And so basically we need to ensure that data is secured along all the layers from encryption data at rest when we don't use it, to using secure and safe transport protocols to communicate between different services. And of course, it's important to use services like AWS, which are secure and compliant, and use them in a secure way.
I think that's a great answer. I'd just add, as well as the type of model that we're using and where that data goes, like Max has alluded to, it's also about what we're feeding into that model, because there obviously is capabilities of being able to de-identify or pseudonymize that data before it hits the model. And then you bring it back out of that model once you've got the output, and you reassociate it with that patient's information. So you can kind of tailor it from two ways, can't you? You can control the model and the hosting itself, and then you can control the inputs and therefore the outputs of that model as well. So there's kind of two levels of security and data governance that you can apply to your product or your innovation.
Yeah, totally agree with that. And actually, I want to highlight what Michael mentioned about anonymizing and pseudonymizing data before the actual training, because sometimes in the industry, we focus too much on putting together guardrails at the inference, but not focusing so much on the security at the training aspect of it. And having this data anonymized or pseudonymized is avoiding headaches later. That, of course, we need to put all the measures in place. But when we are working with clean data, ready with no PII data before training, then it makes the security job much consistent.
Thank you. And next question, I guess also like it was touched a bit in every time, but if to sum up, like what measures can be taken to guarantee the safety and reliability of AI in such critical demand?
I guess, yeah. So basically, you need to take care about all the measures, but the most important part that all this should be done not once, like it's not given, and you can't be sure that all these security procedures are followed. So that's why it's important to do security monitoring, testing, and audits regularly to ensure that all procedures are held consistently.
Just to add to that as well, I think Max is totally right. You know, we should be treating AI like any other solution. It goes a step further in healthcare because, of course, lots of AI quickly becomes a medical device because it's making decisions. That's kind of, it's processing an input and changing it and putting out a new output. By definition, a lot of the time that can be classified as a medical device. So it ends up being quite heavily regulated just by the nature of what it's trying to achieve. So you have to align to that regulation and look at the clinical risk, the data protection, the cybersecurity, the interoperability, and also the usability of the output. So, what we say at Bloom is that often there's a product evolution journey because AI as a medical device is about as risky as it gets. So the speed to market, actually developing it might be fine, but actually market adoption might be slow, and it might be high risk. So actually always think, if you're thinking about building AI as a medical device today, then have a think about, is there a SaaS version of this first that we can get to market? We can start to build trust in the brand. Can we then regulate that and make it SAMD, software as a medical device? And then when you've got that digitization and you've already started to get some efficiency gains, then can you include AI and make it even more efficient, even more powerful? And that product evolution might be a 5-year journey, but you're taking your customers along that journey with you. You're building trust with them so that when you do include AI, they're already like, I recognize Bloom's brand. I trust Bloom's brand because I already know that they take our data and our cybersecurity seriously. AI is just another layer and another layer of trust that we now need to build. But you're not going from standing still to sprinting. You're kind of starting from standing still. You're jogging with them, you're running, and then you're sprinting together. So think about your product evolution as well. And we invest lots of money into AI, right? But often because there's a gap in the market, but you have to make sure that there is a market in the gap as well.
Another interesting question that I think would be interesting to hear, like from all of your experiences, is how can we maintain HIPAA compliance when using external AI services for processing audio and video from online therapy sessions?
Like, there is short and long answer. The short, there is no way. So the long answer, to be HIPAA compliant, you need to use all providers in your data flow which are HIPAA compliant. So even you need to sign. It's a bit like a legal even thing, that not so technical. So for example, with AWS, so if you want to be HIPAA compliant, there are a lot of AWS services which are HIPAA compliant, but if you just use them, you are not HIPAA compliant. If you first sign AWS addendum to use only HIPAA compliant service, and you use within your architecture only services which are HIPAA compliant, and you can use external providers, but you still need first to ensure that your external provider knows this. You have a legal agreement with them, and all components of your architecture should be HIPAA compliant, so that the whole solution is HIPAA compliant.
And like another question related to that, I guess, what architectural trade-offs have you found most effective for scaling generative AI in highly regulated healthcare environments?
That's an interesting question. So there is always trade-off between the cost and speed. So basically, if you want to move fast and still be compliant, you need to use a lot of either SaaS services or managed services, which are compliant, because it's much harder to build compliant solutions, custom compliant solutions. I guess that's the main trade-off.
And another question, I think we're short of time, but Saif left another question for us, I guess more for the discussion. Mentioned that it's important to ensure that AI fits into the workflow of applications and products. Oftentimes, we see forceful use of inclusion of AI, which can lead to lower productivity. As a company, we're not fully leveraging AI. What are your thoughts in finding the right use of AI, and how do you typically understand and identify a problem that could leverage AI, and what usually is the thought process behind that?
I guess that's a very good question. And the main point here is probably it could be a whole different presentation just around this one question. But the main idea, so if some process is pricing, so if the cost should be high because the cost of usage of AI usage is high. So if you want to substitute some process with AI, so it should already be pricey, and you want to optimize that. The second criteria is that this process should be not should have at least some tolerance to errors, because there is no AI which can. We already discussed that the mistakes AI can make, but the process you want to substitute should tolerate this a bit, and the price of these errors, there should be ways of minimizing the price of these errors, or ideally to eliminate them with some guardrails or safe rails. And I guess the next solution is the complexity. So the next criteria is the complexity. If the process is complex, meaning that the usual programming is not enough for it, so that's a good candidate for AI substitution.
If I can add to that as well, there's no doubt that AI is sexy, but there's also a point at which we need to think that there's no need to, we don't want to use or build AI for AI's sake, right? We still have to think about the foundational problem that we want to solve. So if you want a hole in the wall, you buy a drill. You could buy a sledgehammer, but you want a perfectly round 4mm hole. Now, if you want 1 million holes in a wall equally spaced, then you're going to build AI around a robot that's going to be able to do that far faster than any human can. But at the same time, it's understanding what problem you're wanting to solve. There's no point buying a robot and buying AI to drill 1 or 10 holes. So don't overcomplicate it. Have a deep understanding of the problem you're trying to solve. Start out with the simplest solution, because that's probably going to be the cheapest. It's probably going to be the fastest to market. It's probably going to be the most trustworthy. And then as you build a bigger problem, or you find bigger problems, and you start to build in that AI and that automation capability and that scalability, because it is expensive. Like Max says, it can get very expensive at scale, but you're working at scale. So it's all relative to the size of the problem that you're solving, and that can't be understated.
Okay. Yeah, so we shared it on time. So there were a lot of questions asked before the session, during the session, that are still unanswered. So please feel free to connect with all of us and follow up with us. Also, we will be posting unanswered questions later on our social media and other resources, so feel free to follow us there. And thank you everyone again for your presentations, insights, and sharing the experience. I guess that was really valuable for our audience to get more light on this topic. Thank you everyone for joining the session today. So again, if you have any other questions, please feel free to reach out to us, follow us on LinkedIn and other platforms. And yeah, it was a real pleasure to host the webinar, and thanks again for joining. And yeah, have a great night. Thanks everyone.
I would
Thanks,
like just
everyone.
Thanks, everyone.
if you can help us fill in the CSAT survey that we posted there, it will really help us to improve. And thanks a lot for having us.
Yeah, thank you.
Thanks, everyone.
Thank you. Thank everyone for attending.